Hello everyone, my name is Rahul Soni and I welcome you all to my channel. This video will be the first video in the playlist Workshop on Arduino and ESP boards, which I'll be creating on Arduino and ESP microcontroller boards. Together we will understand different components and sensors. We'll also understand how the microcontroller boards are able to control these devices, these sensors. Together, we will also develop various projects, starting from the most basic ones like blinking of an LED, internal LED, to very complex ones like robotic car, which can avoid the obstacles in front of it and change its course, and like home automation systems. But that's not the limit. We will also learn how to debug and troubleshoot the program. I'll be creating so this is a complete playlist which I'll be going to create, and in each and every video I'll tell you more and more about these microcontrollers. So in a single video, I'll not like to bombard you with all the information because that will be very difficult to grasp and understand. So by the end of this video, you would have understood what is the basic workflow, how to code and upload a program on a ESP32 or a ESP8266 or a Arduino Uno or Arduino Nano board. Yes, I'll be using 4 boards. I'll show you how these boards, microcontroller boards, look like, right? If you are excited to be a part of this journey with me, then I would request you to like and subscribe to my channel so that you are notified for each and every new video which I create and present to you. Now let's deep dive a little bit into the world of microcontroller. Each microcontroller board is different from another one. So usually these boards have different number and different type of pins, broadly, which can be categorized into digital input output pins, power input output pins. Apart from this, analog pins, PWM pins. Power can also be provided by, instead of pins, it can be provided through USB ports and even some batteries as well. Like some of the boards do have sockets for batteries also. Apart from this, on a regular board, you will also find the main IC, which will be controlling or which will be the brain of the whole board itself. You will find voltage regulators, which will regulate the voltage coming into the board so that the board does not blow off with more voltage if you pass to it, but there is still a certain limit. You'll not be able to pass the AC main supply to these boards. You'll not be able to supply more than 9 to 12 volts on these boards, right? Apart from that, you'll also find some LEDs, which would be power LEDs or serial communication LEDs. Power LEDs would indicate if the board is on or off. Serial communication LEDs would represent if the data is being transmitted or being received. So they would kind of blink or be on a steady blink, steady on mode. Additionally, some of the boards also have features like Wi-Fi, Bluetooth, and other features also, and other sensors as well, like gyroscope, touch, temperature, these kind of sensors also. Some of these microcontroller boards do have displays also inbuilt on top of it. Battery sockets to provide them power directly via batteries. So each board is different than the another one. So how do we understand about them? So we need to understand that pinout diagram in detail, what each and every pin is doing. But don't be scared. I'll tell you about these boards, the pinout diagrams later on in my video. So right now, let's start with the program. But to follow along with me, you will need a microcontroller board, right? So let me show you how these microcontroller boards look like. This is an Arduino Uno board. This is an Arduino Nano board. This is ESP8266 board. This has a Wi-Fi on the board itself. This one is a ESP32 board, which has Wi-Fi, Bluetooth on board, plus it has multiple other sensors as well. So we'll learn about these microcontrollers in detail. And apart from that, I can also show you one another board, which is from Raspberry Pi, called as Raspberry Pi Pico. This board has been created by Raspberry Pi, which usually creates like microprocessors, but not microcontrollers. To program on the speaker board, you will need to program on MicroPython. But right now, we are not going into it immediately on our first lecture. We'll certainly go in some of our later videos. Also, I'd like to tell you that I purchased a complete kit from Sun Robotics, which includes like 100 plus components from Flipkart. And I purchased it for around a price of 5,000 rupees, Indian rupees. I'd like to tell you that if you are a newcomer or a newbie in this world of microcontrollers and coding with microcontrollers, then I would suggest you that go for microcontrollers like Arduino Uno or Arduino Nano, because those ones are like pretty cheap, and also like those are very easy to program. They do not have like Wi-Fi or Bluetooth, although like you'll find a lot of library support for them, and like online you will find a lot of reference materials and code and samples for them. So until and unless you get hang of that, like you are very comfortable with these boards and you have done a lot of programming with them, then it could be a time to jump onto ESP boards. Although with my videos, all the playlists which I'll be showing you, I'll be coding on all the four boards which I have, like ESP32, ESP8266, and Arduino Uno and Arduino Nano. So it would be a good video for you to understand and grab like what are the differences between each and every microcontroller, right? If you would like to follow me on LinkedIn, then this is the LinkedIn URL for my profile. You can follow me on LinkedIn as well. So let's understand what is a Arduino or ESP. As I already told you, like both of these are microcontroller chips, which can be programmed to control various kind of sensors and devices. We already know that, right? Now, Arduino project was started at IIDI Institute, Italy, and ESP boards are produced by Espressif Systems. So both have their different origins. Now, the most popular boards from these Arduino and ESP are Arduino Uno, Nano, ESP32, and ESP8266 that we also know about. But there are other boards as well. Links for that I'll be dropping into my video's description section. You can have a look at it. There are multiple other boards which are available, right? Now, let me tell you why these boards are very popular. These boards are very popular because of their price point. This price point at which they are available is like in Indian rupees, somewhere around from 300 rupees to like 600, 700 rupees. That's the range in between it is available. And it depends upon like from which website do you buy it. In US and other countries, it is available for usually as a price point of $5 to $30 or $40, right? So it's pretty cheap comparatively. Now, next thing is these boards and the programming on them is cross-platform. Cross-platform, by cross-platform, I mean like we can code on them using Mac, Windows, Linux as well. And it's very easy to program on them, like using very simple language like C, C++. It's completely open source. The hardware is open source and the software is open source. Now, let me tell you about the program lifecycle. This program lifecycle means all the steps which are required to do before you can upload your program on the microcontroller board and make the board do whatever you want to do, right? So there are basically like, I think around 5 steps which are required, but it depends upon the complexity of program as well. So the step maybe can increase by 1 or 2. But for our basic program, which should be like blinking of an LED, we would need only just 5 of these steps. And maybe in future, when we develop more and more complex programs, that time we can increase 1 or 2 more steps, right? The first step in our list would be to install an IDE. What is an IDE? IDE stands for Integrated Development Environment. Integrated Development Environment is like basically providing you an editor where you can code. Editor like simply like a notepad, but maybe more intelligent than a notepad, which can perform more job. Like maybe you can compile your code. Second step would be to connect your board with the computer. Once you have connected, the third step would come into picture is installation of drivers. but that's an optional step. I'll tell you why it is optional once we reach to that step. The fourth step would be to start programming. That would be the step where we actually code. And the fifth step would be to upload the program on the microcontroller board. So let's jump on to the first step. Now, the first step about installing IDE, I'll be going to tell you about two IDEs. Arduino IDE, which is very famous and kind of is being recommended by each and every YouTuber or any online tutorial or forum, wherever you start learning or you begin in the world of microcontrollers, right? Because this is directly being provided by by Arduino.cc. Let me show you by opening this link. So when I click on this link, I can see like the installation steps for installing this IDE for Windows, Mac, and Linux. So these steps are pretty much very easy. And then a portable version is also available for Windows and Linux. Now let me tell you about the second IDE, which I'm going to talk about, PlatformIO. But let me tell you, like, these are not only the two IDEs which are available for programming. There are multiple other IDEs, but these two are very famous ones. That's why I'm talking about them. Why I'm talking about two IDEs? Do we need two IDEs? No, we do not need two IDEs. We can get our work done with only one IDE as well. But Arduino IDE, although is more famous, everything, but I do not kind of recommend it. PlatformIO, being a plugin, can be directly installed into IDE like VS Code from Microsoft, Eclipse, which is open source. From IntelliJ side, like a C-Line is there, and then Sublime, which is an editor, and Atom, which is an editor, and many other editors or IDEs are available where PlatformIO can be directly installed. I have also done one video like why Arduino IDE is the worst IDE and is not recommended. Like, I'll not go completely deep dive in that if I am looking for, but let me just tell you in short, basically when you are working on an IDE, you expect like code correction, automatic code correction. Next is like automatic code suggestion, like some of the basic codes like functions from the libraries, directly from the Arduino libraries. We might not be knowing about them, but when we start typing about it, like we'll get a lot of suggestions. We can use this method, we can use that method, and that would be very helpful for a newcomer, right? Third point I would like to tell you is like we can open any library functions also. Like when we highlight the function directly from the library, we can just highlight it, click control and click, or we can click on command and click. So that way we can open a library functions as well, which is not possible on Arduino IDE. And opening of multiple tabs, debugger, code analysis, all of these features are not available. So let me show you why I'm saying like Arduino IDE is not a suitable IDE. So this is how Arduino IDE looks like. It simply looks like a plain old notepad, which is just having a this is a basic sketch. When you open the IDE, you get a plain sketch which it expects you to code on, and then there is this verify button which basically kind of compiles the code. This is for uploading of the code, and then this button is available as a serial monitor, which tells you like kind of gives the output as in like you can write some log statements which if you want to print them out on the serial port, so those get printed out. We'll learn more about like what is the serial monitor and all that stuff, so don't worry about it. But all I want to tell you about is the UI interface kind of pretty much sucks over here. It does not provide a lot of features and anything over here. The next IDE which I'm talking about, PlatformIO, let me click on this link. The steps are pretty easy. All you have to do is like you need to download Visual Studio Code. Once you have the Visual Studio Code, then you need to open the Visual Studio Code extension manager. Then you need to like search for Platform IDE extension and then install it. That's it. It's pretty neat. So if you want to follow along with me, then I would recommend like install PlatformIO, right? And even if you don't want that, still the code which I program, you can copy it and directly run it into Arduino IDE. It will work. If you face into some difficulties while porting my code into Arduino IDE, then you can ask me in the comment section. I will surely help you out. And if you have some difficulties while installing these IDEs, whichever IDE you choose to go ahead with, and if you face any difficulties, then also you can ask me. So now let's jump on to the second step to connect your board to the computer. All you have to do is you need to have a USB cable to connect your laptop and your board, and that's it. Like you're done for the second step, and that is how you'll be uploading your program from your computer to your board. Now let's jump on to the third step, which is kind of optional and describes about how to install the drivers. This step is only applicable for you in case if you're going to choose Arduino IDE and you program on non-Arduino boards. So like if you choose like PlatformIO and use any board, then this is not applicable for you. If you choose Arduino IDE and program on Arduino boards like Arduino Uno and Arduino Nano, then this is not applicable for you. So it's only applicable in case like if you're choosing Arduino IDE to program with ESP32 or ESP8266 board. What you need to do is in Arduino IDE, go to File and Preferences. Once you're there, then open the section of additional board manager URLs and enter the URL, the one which has been highlighted in yellow. So there are two URLs separated by a comma. All you have to do is you have to copy both the URLs separated by a comma and then enter in the field with called as additional boards manager URLs. Once you're done, like come out of it, click OK and come out of it. And then go to Tools, Boards Manager. And then the step in step number 3, A or B, it depends upon which kind of a board you're going ahead with. If you're going ahead with ESP32 board, then you have to search for ESP32 and then click on installation of ESP32 by Espressif Systems. If you're going ahead with ESP8266, then search for that, press install for ESP8266 by ESP8266 community. I told about these steps like verbally, but I'll be also providing the links for how to do these steps step by step with some pictures along with it. Like these are some external links. I'll just link them in my video. So it would be like very easy for you. I don't need to go into these steps manually. Now, this is the favorite part where we would be actually coding. The fourth step where it would be about start programming, the first program of our whole playlist, which is about LED blink program. Let's understand about this code, the code which you're seeing in the right side of the screen. We are seeing like two functions. The setup function basically runs only once when you power on the board or reset the board. So whenever you will power on the board, this function will execute, but only once. So next time, if you shut it down and then power it again, so it will run again. So it's not for the whole life cycle of the board, but every time you power it on, okay? Next thing is, loop function is kind of a function which keeps on running every time. It runs over and over again, like till the time the board is on. That's why the name is loop, okay? Now let's understand like what are the differences of these. So in the setup function, we do the initialization, basic initialization of our program. And in the loop function, we write actually the body or the business logic. Now let us understand what these statements are, and the whole program is about blinking of an LED. The first step over here says is pin mode. Pin mode is a function directly provided as a library function, and it tells you like it takes two arguments. One, it takes the pin number, and the second one it takes as output. Like if it is like second one it takes as a mode. The mode can be like an input mode or an output mode. So the first argument which we are passing as LED built-in. LED built-in is kind of already predefined variable which automatically like gives you or generates a value based on the board which you are using. So if you are using like a board like Arduino, then this LED built-in will resolve to value 13. 13 is the pin where the internal LED is situated at in Arduino boards. But in ESP boards, this value can be like pin number 2. And in other boards, it will depend, right? Now, Next is the serial begin. This actually tells us about to begin a serial monitor. Like I told you about the button serial monitor. Now you begin the serial communication. You just tell about like this is the bandwidth or the refresh monitor rate for that board. Usually this refresh rate is different for each and every board. So for Arduino boards, it is like 9600, pretty much same for them. And for ESP boards, it is different. I'll tell you whenever we start programming about that. And if we don't write this, then uh, what will happen if we do not write this statement? That also I'll tell you. In the loop function now, the first line which we see is the digital write. This function takes again two arguments. The first argument is the pin number and then the voltage, kind of like a voltage level. So the pin number is again LED built in, which will automatically resolve for each and every board. And the next argument, the value can be like a high or a low. High would mean like turn on the LED, like just send the power on this pin. Once you send the power on this pin, the LED will automatically glow. Then the next statement is serial print LN, LED is on. We are just printing on the serial monitor that LED is on. So that this is kind of an acknowledgement. Like whenever you turn on the LED, just acknowledge it, write a log on the serial monitor, LED is on. That would be very beneficial, usually like for debugging your code and all. Then I am putting a delay of 1000 milliseconds, which is equivalent to a second. So it will just wait for a second and the LED will be still glowing till that duration. Then again, I'm calling digital write function with LED built in and low. Now this will make the LED turn off. So it will kind of off. And then I'll again print off is LED is off on the serial monitor. And then again, I wait for a second. And this thing keeps on repeating over and over and over, which will like make us feel the LED is blinking, like it goes on, off, like that. So this is the code which we will be doing. Now let's jump onto the coding and jump onto PlatformIO. Once you come on the screen, click on new projects. Once you click on this new project, a window pops up where you have to provide a name for the project which you're going to create. So let's give as example 1 blinking LED. And then you have to select a board, and the number of boards available, the support for them is like 997 boards, which is like an impressive number. Almost 1,000 boards available. So you are pretty sure to find your board over here. So I just type in some letters to filter out the list and find a relevant board for me, which would be Arduino Uno, which we're going to use. And yeah, I will upload my code on ESP32 boards also, and I'll show you how we can do that. The framework would be Arduino, and let's click on the finish button. Once you click on the finish button, it will kind of download some libraries for you if you're doing it for the first time. But for me, the libraries have already been downloaded, so it's pretty quick for me. After clicking of the finish button, you will see like this kind of hierarchy structure, the folders available, and the platformio.ini file as well. This is kind of a configuration file for PlatformIO, which tells you about like what kind of different environments we have. So the first environment we have configured is Uno environment. That's the name of the environment. Platform would be like ATMEL AVR. This is the chip, the main IC chip, which is there on the Uno board. And the board name is Uno and the framework is Arduino. That's how you have to configure. Although I didn't do it, like all I have to do is select the few options while setting up starting a new program, and PlatformIO did it for me. Next file which we have to look at is within the source folder called as main.cpp, which stands for main.c++ file. And we will be doing the coding in C++ language or C language. Now you can see like a difference. Like I told you about these two functions, but I didn't tell you about this include statement. So this include statement would be only present if you are coding on PlatformIO and not on Arduino IDE. Arduino IDE automatically includes this library. H stands for header library, right? So Arduino header library is already included in Arduino IDE, but PlatformIO will do it like for you. Once this is there, all you have to do is like you have to type in the function pin mode. Once you like, let me show you again what I did. I just type P and it's telling me like, this is giving me auto suggestion that you can use this function pin mode, and it's taking two variables, the pin and then mode. So this is the feature which I get out of like PlatformIO, which I'll be very much missing in Arduino IDE, right? That this is the reason why I prefer this IDE more. I click on this, type in, and all I have to do is like type in the pin number. I can give the pin number in integer as it says like uint 8 underscore t. So it basically resolves to like unsigned integer of 8-bit. So I can give directly the pin name, or I can use the inbuilt variable name as well, which is LED. All I did is type LED and it's showing me already use it. And it's giving me like this variable resolves to 13 for my board, right? Automatically it's doing that IntelliSense and telling me all of that about me. Sorry, about my board, not about me. So now I need to tell about the mode. The mode can be an output mode. Usually like LEDs are an output devices. After the end of each statement, you have to put a semicolon. If you don't do that, then it will give out some compilation errors at the end. So don't forget about it. Once you have written this, let's add this line, serial dot begin. And then I initialize with 9600. I'll tell you like why this is used, what's the reason for it. It's only to initialize the serial monitor, but what happens with it, that I'll tell you. Next thing that we need to write is call up again another function called digital write. And then we again need to pass in the pin name, which is LED built-in. And I will say as starting with a high. So the value is high, which I'm going to provide. And then let me put on a debug statement, which would just print something on the serial monitor, so serial.print. And there are various options available. So print will like kind of just print on the console, and the next print statement comes, it will print on the same line. But println would like print on the next line. Like the next print statement comes, it would be getting printed on the next line. So that's the difference. So I can use like a println statement, and I can say that LED is on. Then I can give a delay. I can give a delay of around maybe 1000 seconds, which is like a 1000 milliseconds, which is equivalent to a single second. And then I call up this function again, digital write, so that to make this LED go off, and I can send it as low, which is equivalent to make it off. And then again, serial.println as LED is off. Again, adding a delay of 1000. So that's it. Our program is sort of ready. Now we need to do is like we need to save it. If you're using PlatformIO, then it will automatically, like if there is some error, if you did some typo, let's do some typo over here, and it will automatically complain you like by giving this red indicator below this line, which tells you that there is some problem in this code. And you can see also some red indicators over here. It says this, there is some problem in the code, you need to fix it. You can identify that pretty easily visually as well. But if you are not using this PlatformIO, and if you want to do it in Arduino IDE, then there was that tick mark in the Arduino IDE, similar to like this. If you click on this, this will basically compile the whole code. And if we do that in PlatformIO also, we'll get the same result, like it will give us an error. So we got an error that class hardware serial has no member named Beggy. Okay, now let's just add the N and fix the typo. Once we have fixed it, let's compile it again. Once we compile it, like it's compiling and says success, like the whole program got compiled in 1.48 seconds, which is pretty good. And it also tells us like how much of memory it will be utilizing, like 10.2% and flash this much. Now the next step would be just to connect our board and then upload the code on that. To upload your code, all you have to do is you need to click on this arrow button. Once you click on this, then it will upload your code. Make sure like your board is connected with your computer with the help of a USB cable. If your board is not connected, you will get some errors, and it would be better if your board is connected for the first time at least. Now my board is connected and I am uploading the code. My code got uploaded successfully. Now I've already hit the upload button, and once I hit the upload button, this is how it happens on my Arduino Uno board. The LED, if you can see, like is blinking. The orange LED is blinking, and the green LED, which represents the power, is like steady, which shows like about the power thing. And that's pretty much it. Like we have already reached to our fifth step, which is like kind of the uploading of the program. And we have already successfully done it on the Arduino Uno board. Now let me tell you like how do we need to do for other boards. If I want to upload the same program on Arduino Nano or ESP32 boards, platformio.ini, the configuration file. Yeah, I'm talking about the same file. And in this file, you have to provide in the configuration for these boards. So if you do not know like what would be the configuration for your boards, what you can do is head out to this website of platformio.org and go to the homepage, click on the boards, search for the board which you're looking out for. For our case, like if you are looking out for Nano board, the board which I have is this one, the third one in the list, Arduino Nano at Mega 328. So let us click this. Once I click this, I'll be coming to a page which tells me about the configurations which I need to do. So these are the configurations. All I need to do is copy them and put it in this configuration file, and then only need to copy from here is framework. Framework will be Arduino. I can like keep both these configurations at the same time, like both these board configurations also present in the same file, and I can upload the code to both these boards together. What I'll be requiring is to connect both these boards and then click on the upload button, and automatically like my code will be getting uploaded on both of them. Sometimes you might face some error while doing this kind of a way that both the boards are simultaneously connected and you are uploading the code. What you can do is maybe you can comment out one of the uh, configuration. For commenting it out on a Mac, you can use command forward slash, and on a window you can use like control forward slash. Once you do this, then the only one configuration will be remaining, and then you can just save it and then upload it. So PlatformIO will automatically take care of identifying which board is active from the configuration and the one which you have connected with your computer, and it will upload the code. And voila, like everything will start working on. If your program is not working, then there would be some steps how to like troubleshoot. The biggest point, at least for this program, would be like when you connect your board with your computer, then at least one LED should come up immediately when you connect it itself. That would be the power LED. If the power LED is not on, that means like board is faulty. It's not getting the power, or maybe you're not providing the power, or the connection is loose. Just connect it again. If still it doesn't help and the LED is not on, then board is corrupt. Sorry to say. As I told you, like how to configure a Nano board, it will be very similar to configure on a different board as well. All you have to do is head back to this website, go back to the boards, and search for the board which you have. If I am going to do it for my ESP32 board, so let me search for ESP32, and like although you will get a big list, but if you are aware of the exact board which you have, then directly use that name. The board which I have is the DevKit ESP32 board. So let me directly type that. And my board is from Do It ESP32 DevKit V1. So try to get the same board if you're going to use ESP32 board. If you have another board from ESP32, then try to find that from this list and open this page for the configuration. Over here, you will see the configurations which you need. Copy them and paste it over here, and also add the framework in this configuration, and then upload. That's it. That's the whole story of this program. So once you have uploaded your code onto the board, microcontroller board, so that's it. Like you have completed the first program in the microcontroller world, a Blink LED program. So you should be very happy with it. And in case if it didn't work for you, what you can do is you can put in your problem, the issue which you faced in the comment section of this video, and I'll try to help you out. Useful links for you with information on like the different kind of Arduino boards which are there. So the first link tells you about it. The second link tells you about like different kind of ESP boards, installation step of Arduino IDE. The fourth link is about like installation steps of PlatformIO. And the fifth one is about the YouTube video which I did describing or doing a comparison between Arduino IDE and PlatformIO, a detailed description video, and which also tells about the step-by-step installation of PlatformIO IDE. And the last links are about like how to install the drivers for ESP32 and ESP8266 boards in Arduino IDE. So if you like the content of this video, then hit on the like button and subscribe to my channel. Subscribing would be a way to show support for my channel. And because this is the first video, I might have gone wrong at some places. I might have overemphasized few things, but I tried to give the content as good as possible to you. I tried to explain most of the things, but always there is a room for improvement. You can like tell me, give me feedback and review comments about my video in the comment section. I'll certainly want to improve myself. And if you need any help on any of the areas or setting up of any IDE or sensor or any of the projects, then I can also help you out. Mention in the comments like what and where you need a help. Just hit on like and subscribe button. Thanks, man. And that's it from my side. Bye.